Thanks, Richard, for taking over. So my name is Oliver Gannertz, and I'm member of the architecture working groups in Nautosar. And today I will present you the classic platform enhancements. So in total, I have 4 different enhancements today with me. So starting with the first one, classic platform flexibility. So this concept was that huge that it's across multiple releases. So today I have part 4 to 7. But just maybe a short recap, what is the classic platform flexibility about? So the idea is to have a collaboration of different teams working on the same project. The idea is here to create software clusters quite similar to the adaptive platform so that each software cluster can be separately built and also, of course, then separately updated. So then each team can work on different software clusters and then we can combine it to huge project then later on. So technically, this is done with binary objects and binary compatible interfaces between the software cluster and a host cluster. Um, yeah, the first 3 parts was exactly to define these basic functionality and to validate these basic functionality. The validation is not finalized yet, but the temporary results are looking very good. And the next 4 parts are there to detail or to enable the usage of the standardized basic software services. So currently it's more a theoretical approach that the RTE can be used with the software clusters approach, but you can't use any basic software services. So looking to the individual parts now. So the first one, it's about diagnostics. So it's the part 4. So with this part, so-called high proxy modules was added, one for diagnostic communication, one for all this diagnostic monitoring and DDC handling, the diagnostic event manager proxy, and a third one for function inhibition, so that derived from DDCs, you can inhibit specific functionalities. This is quite often used in these large projects, like an engine controller, for example. There are thousands of DDCs and a lot of these inhibitions. But also in this concept, the safety is always an important point. So also here, the concept had a strong look for the safety concept. And the first and most important for safety is always the freedom from interference, because the software clusters do not provide any instant separation feature like a Docker container in Linux, for example. But we realized that the existing partitioning feature of the host platform can be used for this separation. So in that sense, it's even possible to separate in one software cluster to have multiple partitions, one for QM and one for ASIL, for example, or different ASIL possibilities. Next, for the safety concept is always the supervision, so the watchdog handling. So you have from the safety who Cypher presented here also extensions to the watchdog manager, but here it's the focus how to use the watchdog manager, all these supervisions in such a software cluster. Therefore, also such a high proxy module was added here with a local configuration so that each software cluster can have an independent configuration and also a local calculation of these results. This local calculation is in a hierarchical order combined in the host software cluster, so forwarded to the host software cluster that it can be combined there. So with this, we have the possibility of sample recovery actions and also have the opportunity to have cross-software cluster logical supervision so that you can, for example, also measure deadlines between different software clusters which are developed by independent teams. And the last point in this concept is about communication. So we have always the signal-based communication through the COM module, and we have the SOM-IP service-based communication via the large data COM module. Both are now also provided as a high proxy module to have here an optimal support for the external communication also in these software clusters. This is, for example, essential if a signal is received in multiple software clusters. So we need to distribute this to multiple software clusters in a most efficient way. And therefore, here features are added to the PDU router and so on. But coming to the next topic, memory stack rework. This is also a very huge topic because currently in AutoSAR, or in the past, AutoSAR concentrated on non-volatile data storage so that I can, from a software component, store my local data in non-volatile memory. But more and more use cases are coming up in the market, which also requiring here additional needs. So for example, the over-the-air update, so that I need to be able to address also in application software the code flash to write to a B partition, for example. Also on SOC devices, we have multiple CPUs, or like a hardware secure module, accessing also the flash in parallel. So we need to have synchronization mechanisms and also more demands for a common API for different memory devices. So what is done in this rework? So on the left, you see the NVM, MEMFV, and AR. This is the existing non-volatile data storage, and we have new memory access layer and the different memory driver modules. So the memory access layer is newly introduced, and also the memory drivers are simplified. So this memory access layer is doing all the common functionality for all these drivers like queuing, page handling, multi-sector switch, and so on. And also provides a common interface for further modules like this over-the-air update client, which are directly accessing the flash, not via flash EEPROM emulation and so on. But also here, safety considerations is always an important topic because if we have access to program flash, we also need to check that the accidental override of such program flash is prohibited, and therefore this memory driver can be stored somewhere else, which is not accessible normally, and then loaded dynamically in runtime to make it available, for example, for the OTA client to write to the program flash. So this was an essential update to our refactoring of the AutoSAR memory stack, which was demanded in the market for a long time. But it's not the only enhanced topic. So the next enhanced topic is OBD and UDS. This is also very important because it's about legislative OBD diagnostics. And OBD on UDS is the replacement for OBD2 diagnostics, which is usually mandatory for combustion engines vehicles sold in the whole world. OBD2 is in US standard, and each country has derived standards from this OBD2. OBD and UDS, it's starting in 2023, and it's getting mandatory for newly produced vehicles in 2027. So it's really a must that we support this in AutoSAR, because now the vehicles for this period are started to develop. And CARB is normally also a leading, or the ARB in the US is a leading legislation. So we also assume that many other countries will follow here the ARB and will also introduce OBD and UDS. And also in the ARB in US, it's the discussion if zero emission vehicles also needs to be complied to this new standard. Currently, zero emission vehicles are not mandated to support OBD2. Why is this change done at all? Because you can say zero emission, it's not needed OBD at all, but technically wise, we're running out of free to buy DDCs. This was mainly due to the electrification of the vehicle, of the hybrid vehicles, because there was a lot of new DDCs added. And if we continue with all these new technology which are currently coming, it's just assumed that we run out of free to buy DDCs, and therefore this OBD UDS provides here more space. And besides that, also further functionalities like more fine-grained readiness for the IM stations, or the in-use performance ratios, also more fine-grained, more freeze frames for repair analysis. And of course, it's also future proven. It's ready for Ethernet with OBD and UDS. OBD2 was just limited to CAN, but currently in US, it keeps to be limited to CAN because it was too costly to update all the IM stations with Ethernet. But maybe in future, I would assume there will be a switch. What is done in AutoSAR? So all the necessary diagnostic services according to the SAE J1979-2 was added. The new freeze frame was added. Also the calculation monitor activities ratios, the impair ratios. So all to support this OBD and UDS functionalities in AutoSAR. Last but not least, there is also a C99 support in AUTOSAR. So after more than 20 years of introduction of the C99 standard, AUTOSAR also now switches to the C99 standard. It will allow to reduce complexity in future. So in the past, not certified compilers was not available. Therefore, AUTOSAR did this change this late. And for example, the compiler abstraction, which is already set in this release to obsolete and will be removed with the next upcoming release. So in architecture, we decided to focus in the classic platform future to go to purely NCC and to support also in the focus 32 and above microcontroller architectures. So that's also all from my side. I think the last important message from my side is that the classic platform is still evolving. We will always continuously to adapt the classic platform to new market needs, as I show you with the current enhancements. That's all from my side currently. So I will give over to Tony. Tony, so it's floor is yours.